Hey, statistics students, our goal today is to find a least squares regression line that describes the relationship between two quantitative variables. So right now, our question of interest, what we're going to base everything over today is what relationship is there between your high school GPA and your college GPA at the University of Minnesota? What we have right here is we have two quantitative variables. Our high school GPA, we are calling that our explanatory variable that is going to influence our response variable, our college GPA. We have 10 students where we gathered their data. And the first thing before we even find this least squares regression line, which is you maybe know as the line of best fit, we want to plot the data. So I plotted that data there. And when I plotted that data, I looked at my minimum and my maximum and decided what my scale would be, as well as for the y-axis. Right here, I looked at my minimum and my maximum and decided what my scale would be. Again, this y-axis here is the college GPA. And the x-axis is the high school GPA. So you can see someone who's a 2.0 GPA in high school, has a 1.6 GPA in college, so on and so forth. Just a quick review, if you were asked to describe the distribution, you want to think of the acronym SUDS, right? S stands for shape. Shape would be, if I'm going to take a line and I'm going to plot it, and I want about half the points above and half the points below, and remember, it does not have to start at the origin. You're just kind of trying to figure out where that y-intercept will be, where, again, half the points will be above, half the points will be below. Maybe approximately right here, maybe up just a touch. Okay. That's our least squares regression line, our line of best fit, as you learned when you're probably in 8th, 9th, or 10th grade. Okay. Maybe even 11th. Is this shape now a line? Or is it a U like exponential? More than likely in our class, it's going to be linear. Okay, it's going to be a straight line. That's what we're looking at. You would be, is there anything unexpected? Is there that Shaquille O'Neal factor that I talked about earlier? Is there someone over here, someone down there? Some kind of that lonely point, and I don't see that at all here. So we would just say none. Okay, the direction is when we're reading left to right. Is it going up or is it going down? And it looks like this is a positive direction. And then the strength. How strong is it? Are they all hovering around that line that we just drew? Or are they kind of, is there a little bit more variation between the line? I would say that this is maybe moderately strong to strong. How we can confirm it, right now we're just using our eyeball test, right? How we can confirm it is we can go ahead and we can find that correlation coefficient, which we'll find here in a second. That's not the goal today. We've already found that correlation coefficient. The goal today is actually to figure out what this line will be. In algebra, you knew this line is y equals mx plus b. In statistics, we call it y hat, which means our predicted y, because we use this line for prediction. Y hat is equal to a plus bx. Okay, in order to find this line, where a now is our y-intercept and b is our slope, we need to go to our graphing calculator. So get that graphing calculator out now. When we go to that graphing calculator, we want to put our X list in L1. So our explanatory variable goes in L1 and our Y list in L2. So let's do that now. So I'm going to go to Stats. I'm going to go to Enter on Edit. I'm going to go up to L1 and L2. And I'm going to clear these out. Again, remember when you do that, you need to make sure that cursor is on the L1. Same thing here on L2. Make sure that cursor is on the L2 and clear that out. Okay, next what we want to do is we want to enter that data. Okay, so my first one is 2. Then I have a 2.2, a 2.6, a 2.7, a 2.8, a 3.1, a 2.9, a 3.2, a 3.3, a 3.6. Okay. Then I want to go over to the Y and I want to type that in 1.6, 2.0, 1.8, 2.8, 2.1, 2.0, 2.6, 2.2, 2.6, and 3.0. Just double check that you have them all right before you proceed, just to make sure. It takes a little more time to check, but in the end, it's less time in case you make a mistake. So you want to catch that mistake So we have 2 and 1.6, 2.2 and 2, 2.6, 1.8, 2.7, 2.8, 2.8, 2.1, 3.12, 2.9, 2.6, 3.2, 2.2, 3.3, 2.6, and look there, I made an error. So good thing I caught that, huh? 3.6 and 3.0. Very good. All right. What we want to do next to find that line. Now you'll notice I'll have an L3 over there, probably from my AP stats working with them, or maybe regular stats, I don't know, but we're going to clear that out just to look nicer. It doesn't matter though. Okay, the next thing we want to do to find that line, okay, so we just entered it, right, stat, edit, and we put it in L1 and L2. Next, what we want to do is we want to hit stat, we want to arrow over to calc, and we want to go to number 8, ln reg A plus bx, just like we did for the correlation coefficient. If you have an older calculator, you can go ahead and just hit enter now. You won't see this screen. But if you have my calculator, your X list is L1, your Y list is L2. You shouldn't have anything here. And you just go down and you hit calculate. I'm going to pull my fanciness over, I always call it. And so we can look at this screen more. So 0.69, and I think that we said that was about a moderate relationship. Moderately strong is fine to use as well. Okay, so we have our relationship here. Y equals A plus BX, okay? Now we call it Y hat. They don't put it there like that, but we do that. Y hat is equal to A, and A is 0.43. We're going to use round to the nearest hundredth, 0.43 plus BX. So plus, our B is 0.64, and because this number here to the right of 4 is 5 or above, we're going to round it up to 0.65 times X. Now what's important is we want to highlight what X is. X is our high school GPA. And we're using this line to predict our Y, what our college GPA is. So we're going to put predicted college GPA. So there we did it. We've just found our least squares regression line, our line of best fit. This is the line that's going to model what's happening with our data. Okay. Now, some of you might know, oh gosh, Miss Opal, your y-intercept is in the negatives and our y-intercept is not negative. That's okay. That's just because I was estimating that line. That's just human error. So it might look something a little bit more, oops, come on. See if I can get it here. Something a little bit more like that. That's okay. My line was just a sketch. This is the accurate line right there. All right, now, as statisticians, our goal is not only to calculate things, but to interpret things as well. So we want to go ahead and we want to interpret that, okay? Give me 1 second. I do need to pause it for 1 minute. Okay, so you're going to use this sentence frame to help you interpret what the slope is. So like I said, if you didn't know, this, whatever number is next to the X, okay? This coefficient right here, this is your slope. Always. And this constant here, meaning there's no variable by it, A, that's going to be your y-intercept. Okay. So we have our slope right here. And we have our y-intercept right here. All right, so let's interpret the slope. What does this slope mean for our problem? So you can use this as a template for you whenever you do find the slope or whenever you're interpreting the slope. So we'd say as X increases, so we would want to use what is X. In this case, our X is our high school GPA. So as X increases by 1 unit, so what is a GPA? A GPA, the unit is points, okay? So as our high school GPA increases by 1 point, Y, so what is Y? Our college GPA, we shouldn't say goes up, we should say is predicted to go up. forgive me for that, is predicted to go up or down by blank units. So in this case, our college GPA is our Y. Our college GPA is predicted to go up in this case because our slope is positive. Down if our slope is negative. So again, guys, we just fill in the blank here. Let me talk you through it again. As X, well, X is our high school GPA, increases by 1 point, 1 unit. Y, our college GPA, okay, there's our Y right there, is predicted to go up by 0.65 points. Okay, I just got a phone call, so in case I repeat myself, forgive me. Again, we're just working on filling in the blanks as X, okay, as X. So in this case, our high school GPA increases by 1 point. There's our unit. Y, our college GPA, is predicted to go up, or it could be down by blank units. This right here is the value of the slope. In our units, that's points right there. Okay, so now let's talk about the y-intercept. So the y-intercept is 0.43. When we interpret that, when X is equal to 0, okay, in this case, X is our high school GPA, the value of Y, our college GPA, is predicted to be, whoops, that should be a B, or let's just say it's predicted to equal blank units. Right here, this is the value of the y-intercept. Okay, so let's put this over here then. When high school GPA, that's our X, equals 0, the value of Y, college GPA, is predicted to equal 0.43 units. Right here, that's the value of our y-intercept. Now, why do we use this least squares regression line? For prediction. We plug in the value that we get into our y hat equals ax plus b. We will always be, I have it the other way. Dang it, hold on here. I'm sorry, guys, I have it written right now. Forgive me, that was an old note and I forgot to change that there. Okay, so we're gonna be taking an x value. That's a high school GPA in this case, and we're gonna plug it into the equation to predict the college GPA. That's why we come up with the least squares regression line. So we take this for prediction, right? If a student's high school GPA is 3.0 in high school, what will his or her GPA be in college? So what are we gonna do? Well, we're gonna take our y hat equals 0.43 plus 0.65 times x. We know that x is our high school GPA. We're gonna plug 3 in for x. We're gonna take then y hat equals 0.43 plus 0.65 times 3. We're gonna plug that into our calculator, okay? 0.43 plus 0.65 times 3 equals 2.38, okay? 2.38. So when someone is a 3.0 in high school, they are predicting that the GPA will be in college will be 2.38. Now, there's an issue that can happen when we're using the line for prediction, and that's something called extrapolation. This is using the line of prediction for data outside of the range of the collected X values. This is risky. So the collected X values, what are they, you guys? The collected X values go anywhere from our minimum of 2.0 to our maximum of 3.6. If we have anything outside of these numbers, so anything below 2 or above 3.6, that's called extrapolation, and that's a risky prediction. So you can see here, if a high school student has a GPA of 3.8, what will his or her GPA in college be? Well, 3.8 is higher than 3.6. We can't guarantee that this model will keep on going the same way. So what we have to say is we have to analyze this and say, we are not going to use the least squares regression line for prediction because it is extrapolating. Okay. And we can be done just like that. So what should we have learned there? It's important to note when you are looking at whatever X value you're plugging in, making sure it is in the range of the collected X values. Otherwise, it's considered predicted. Okay, what should we have learned today, guys? How to calculate a least squares regression line on the graphing calculator. Reviewing how to describe the relationship. Knowing how to interpret the slope and the y-intercept. Knowing how to use that line for prediction, and finally knowing what extrapolation is. Let me know if you have any questions. I am here for you guys, and have a wonderful day.